Hello students. We have been discussing about the chapter number systems. There in the previous class we have discussed about different types of sums where we need to rationalize the denominator. Here we have taken one more sum to rationalize the denominator where there are three terms in the denominator. You can see it's 1 by root 3 plus root 2 plus 1. If there are only two terms, then generally we multiply it by the same term with opposite sign in both numerator and denominator. But here we have three terms, so what we'll do, we'll have to make group of two terms. Here you may take these two as one term and one as another term, or else 3 as one term and this as another term. And here we have taken root 3 as one term and root 2 plus 1 as another term. So as usual process, we have multiplied both numerator and denominator by these two terms with opposite sign, that is minus. And then here we have used a square minus b square identity. Then this is root 3 square, so 3, and here we have used a plus b whole square identity. So a square plus 2ab plus b square. Then simplified, root 2 square is 2, then this will become 2 root 2 only, and 1 square is 1. Then we have removed root over this bracket, and then due to this minus sign, all sign will change. So minus 4, and this will become minus, this will also become minus. So simplified, and here we have got minus 2 root over 2, and numerator is same. Now here we have taken minus 2 common. Without taking common also we can do, because here this is again one irrational part, so this part again we have to rationalize by multiplying it with the same term but opposite sign. You can say this is 1 plus root 2, so we'll have to multiply by 1 minus root 2 with both numerator and denominator. Or else at this step also you can do the rationalization by multiplying it with minus 2 plus this term, that is 2 root 2. So here we have done in this way. Now we will multiply both numerator and denominator by 1 minus root 2, and same time we will multiply with numerator also, and this will be our one term. Now below, leaving this minus 2, rest part we will use identity a plus b into a minus b, so it will become minus will be as it is, the rest will be 1 square minus root 2 square. And then here you can simplify by distribution. 1 you can distribute with both, and minus root 2 also you can distribute with both. Then first let us see the denominator part. So this will become minus 2, and here 1 minus 2, and now in denominator, so here we have done simplification. Then next we can find out like terms, this minus root 2 and minus root 2 like terms, rest this root 2 square will become 2, so you can write that root 3 minus root 2 minus root 2, these we have written together, then minus 1 minus root 6, and minus this root 2 square will become 2, and below we have minus 2 into minus 1, so this will become 2. So minus 2 into minus 1 will become plus 2 below, and here root 3 will be as it is, then minus root 2 it will become minus 2 root over 2, then minus root 6 will be same as it is, then minus 1 and minus 2 will write as minus 3, and that will be the answer. As the sum has 3 terms in the denominator, that is why we have rationalized these ones here at this step, making 2 group, and later on we can see we have one more root over term in denominator, so that is why once again we had to go to the process for rationalizing the denominator, and that way we can rationalize denominator of this type of sum. Next we'll discuss about few laws of exponents for real numbers. Here these identities you might have got in earlier classes, but once again we'll discuss because this will be requiring for simplification here. First of all, you can see a to the power m into a to the power n. When the base are same, then in multiplication we have to add the exponents, that is m plus n, and then next when the base are same and we have to divide it, then we have to subtract this exponent. So a to the power m divided by a to the power n will be a to the power m minus n. Next, for any two term a into b to the power m, that will become a to the power m into b to the power m. That means this exponent will have to distribute to both the term as exponent only. And here also same, a by b, this exponent we have distributed a to the power m divided by b to the power m. Remember, this distribution of exponent is valid only for multiplication of terms and division of terms. Next, 1 by a to the power m. If we need to bring this denominator to numerator, then the sign of exponent will change. So that means this a 1 by a to the power m will become a to the power minus m. Similarly, 1 by a to the power minus m, if we bring it in numerator, this will become a to the power plus m. So when we'll bring it here, this minus plus will become minus and this minus will become plus. Then using the same a by b whole to the power minus m, then if we write the reciprocal, b will come up and a will come down, then the exponent, this negative exponent will become positive. Reversely again, if we write from here to here, then again this exponent sign will change. So these are few of the properties. Next, about this root over a we discussed in last class. Root over a we can write it as a to the power 1 by 2. Now remember, this is called square root. Square root means a to the power 1 by 2. Now this is called cube root. Here 3 is written, so this in exponential form we'll have to write it as a to the power 1 by 3. Similarly, if we have 5 here at this space, so then we'll write it as a to the power 1 by 5. So this we'll call as fifth root of a. Next, if there is one exponent over exponent, that means a to the power m whole to the power n, then this exponent will be multiplied with exponent. That means a to the power m whole to the power n will become a to the power mn. And using this, if we write 7th root of a whole square, so then 7th root of a means it will become a to the power 1 by 7 whole square, and then this 2 and 1 by 7 will be multiplied, so this will become a to the power 2 by 7. To use laws of exponents, we have taken some examples here. This is one question. You have to evaluate this, which is 8 root of 6561 by 65536. So to simplify this, first of all we have to convert this number to exponential form. So for this we will have to factorize as and the way we used to do earlier. So we have divided it by 3. So we have got 3 to the power 8, and denominator we have divided by 2 because this is even number, and keep on doing. So we have got 16 number of 2's. So here this is converted to 3 to the power 8 and denominator 2 to the power 16, and this is 8 root, so this will become to the power 1 by 8. Now this exponent will be distributed with numerator as well as with denominator of the exponent. So 8 into 1 by 8 cancel, 3 left in denominator, 2 to the power 16 into 1 by 8, so 2 to the power 2 left. So this is the answer. Next sum we can see, you have to evaluate 0.000064 to the power 5 by 6. So first we have removed 0 by multiplying it with this also and dividing also with this 1 and 60, because after decimal we have 6 digits. So now 64 means 2 to the power 6. This way we will have to factorize. So 2 to the power 6, and then this is 10 to the power 6. This 6 we have taken outside, as we got a by b to the power m means a to the power m divided by b to the power m. So from this we can write this also. So that step we have done here. The 6 we have taken outside. Now this will be 2 by 10 to the power 6 into 5 by 6. And now here at this stage, this 6 and 6 can be cancelled. So left with 2 by 10 to the power 5. And then this 2 by 10 we can cancel by 2 both numerator and denominator. So then this will become 1 by 5 whole to the power 5. And then this will be the answer. In the next question, it is given 2 to the power x equal to 3 to the power y equal to 6 to the power minus z. Then we have to prove that 1 by x plus 1 by y plus 1 by z equals to 0. So this relation we have converted into two parts. One is 2 to the power x equal to 3 to the power y, and next is 3 to the power y equal to 6 to the power minus z. Now here this exponent x we will have to remove. So for this, both sides with the exponents we are writing 1 by x as another exponent. So then what will happen, it will be 2 to the power x into 1 by x, and only 2 will left, and then here it will become 3 to the power y by x. Now in the second relation, this is given 3 to the power y equal to 6 to the power minus z. This 6 will factorize into 2 into 3, and then this 2 will replace by this relation. So here what will happen, the base will be everywhere 3 3 3, and then here we will be able to compare this exponent because we need relation among these xyz. So here we are simplifying. 3 exponent of 3 is 1, so we are using this relation. A to the power m into a to the power n is a to the power m plus n. So y by x plus 1 we have written, taken LCM, and then this exponent is multiplied with this another exponent. So now this will become 3 to the power y equal to 3 to the power minus z into y plus x by x. Now comparing the exponents, comparing exponents, we can write y equals to this much. Then we will get this relation, x will be multiplied with y. Then here x is multiplied with y. We have got this relation, converted all left side. Now to get the answer, we are dividing all term by xyz. Then we will get this relation, and this is the required answer. We can see one more sum where these laws of exponents are applied. If this is given, then we have to find the value of x. So here this is 5 to the power 2x minus 1. This 5 to the power 2x minus 1, we can write it as 5 to the power 2x divided by 5 to the power 1. So here we have used this relation, a to the power m divided by a to the power n is a to the power m minus n. So from a to the power m minus 1, if required, we can write this way also. So that we have used here, a to the power m minus 1, that is a to the power m divided by a to the power n. And 25 we have written as 5 square. Now these two exponent will be multiplied with another exponent, so it will be 2x minus 2. Now here also we have used same property, and then this will become 5 to the power 2x by 5 square. Now here at this stage we have taken 5 to the power 2x common, then 1 by 5 will left minus 1 by 5 square. Then this part left, taken LCM here, LCM is 25, and then 25, and then 4 left here, 5 to the power 2x. Now this 25 is multiplied with this 100 and 4 will come down. So 100 if we cancel by 4, 25 left. So 25 means 5 square, here also 25 means 5 square. So again here 5 to the power 2 plus 2, 4, and here it is 5 to the power 2x. Now here also we will compare the exponents of this relation, then we will get 2x equal to 4. Here from we will get x equal to 2, which is the required answer. Let us see one more example. We have to evaluate 3 to the power minus 1 into 13 to the power 0 minus 27 to the power 1 by 3. So here 3 to the power minus 1 we have written as it is into 13 to the power 0. So we know that any number to the power 0 is 1. So here also 13 to the power 0 will become 1 minus 27 in exponential form. We can write it as 3 to the power 3 and whole to the power 1 by 3 is there. Next step, this 3 and 3 will cancel out. Only 3 will left, and this is 3 to the power minus 1. This 3 to the power minus 1 we can write as 1 by 3, because any number to the power minus m equal to 1 by a to the power m, we can write it. So that we have used here minus 3, and now taking LCM it becomes minus 8 by 3. This is the answer. Next, one more example. We have to evaluate minus 3 to the power 4 minus 4th root of 3 whole to the power 0 into minus 2 to the power 5 divided by 64 to the power 2 by 3. So here again any number to the power 0, this we have written as 1, rest kept as it is, then divided by 64 we have written as 4 to the power 3, so that we can cancel this 3, and then 4 and square left. Here in this next step, minus 3 we have written as minus 1 into 3, and minus 2 also we have written as minus 1 into 2, so that you can segregate this minus 1 to the power 4 into 3 to the power 4, and minus here also minus 1 to the power 5 and 2 to the power 5. So minus 1 to the power 5 into 2 to the power 5 divided by this, again we can write in exponential form because 4 means 2 square whole to the power 2. Now minus 1 multiply 4 times, it will become plus 1 into 3 to the power 4 minus, here also minus 1 multiply 5 times, odd number of terms means minus left out, minus 1 and into 2 to the power 5, and this is divided by 2 to the power 2 to the 4. Here minus 1 into minus will become plus, and then next a to the power m divided by a to the power n. So here we have used a to the power m minus n, and then 3 to the power 4 will become 81 plus 2 to the power 5 minus 4 1, so answer is 83.